Okay, for next question, that is question number 31. It's given that a student has focused the image of an object of height 3 centimeter. So object of height 3 centimeter, this is part A. So object is height is noted by h and it's always erect. So it is 3 centimeter on a wide screen using a concave mirror. And for the concave mirror, the focal length is 12 centimeter and it's negative using the sign conventions, because for the concave mirror, this is the concave mirror, its focal length, its focus is in front of the mirror, and this is the pole. The distance between the focus and the pole is the focal length, and this side is a negative side. So focal length is negative, which is 12. The distance of the object, so distance of the object is denoted by u, and it's also in front of the mirror, so it is negative 18. We have to find the values of distance of the image. So distance of the image is denoted by v, so that means we have to find out v, and height of the image. Height of the image is h dash. Okay, let's use, this is a mirror, so let's use the mirror formula. So I'm going to use the mirror formula. So using mirror formula, so mirror formula is 1 upon v plus 1 upon u is equal to 1 by f. So we have to find v. U is negative 18, f is negative 12. Now this plus or minus is minus, we can take, so this is also minus 1 by 12, and 1 by v is equal to negative 1 by 12 plus 1 by 18. So 18 to the is 36, which is the LCM, and this is 12 3 negative 3 plus 2, which is negative 1 by 36. So that means v is equal to negative 36. Negative means that it's formed in front of the mirror and is at a distance of 36 centimeter in front of the mirror. Okay, now we have to find out, second is we have to find out the image height. So for this was his first part, and let's find out. So we know that magnification is given by h dash upon h is equal to negative v upon u. So we are going to use this combination. H dash is the height of the image, h is the height of the object, which is 3, and negative v is negative 36. Use the sign convention. 18, this gets cancelled. So 3 6 r is 18, 6 6 r is 36. So height is negative 6. Negative means that the image is inverted and it's 6 centimeter in size. That is, this is the height of the image. Okay, let's move on to the or part. What is the power of a lens? Okay, moving to part B. Now this is or part B. Now the power of a lens. What is the purpose or what is the function of the lens, whether it's a concave lens or the convex lens? So the function of this concave convex lens is to convert the rays of light. So they bring the rays of light at one point. Now, more they bring the rays of light at one point, the its focal length will decrease, because this point is the focus. So more they convert the rays of light, more will be the focus near the optical center. So that means that the focal length is decreasing, and the degree of convergence for this lens is called its ability, which is called its power. So more it converges, more is the powerful lens. Similarly, for the diverging lens, more it diverges the rays of light, more is its power. So its function is to diverge the rays of the light. So more it diverges the rays of light. For these rays of light, if we produce them backwards, they will intersect here, which is the focus. So distance from the optical center and the focus is the focal length. So more they convert the rays of light, so more they convert the rays of light, more nearer will be the focus and less will be the focal length. So focal length decreases and the power of the lens increases. So we can write that the power of a lens is the ability of a lens to convert or diverge the rays of light. So power of lens. So power of lens is the ability of lens. So lenses are of two types. The convex lens will converge and the concave lens will diverge. So ability of the lens to convert or diverge. And what are they diverging and converging? They are diverging the light rays falling on them or falling on it. So that is the power of the lens. Instead, you can also say for this, you can also write the degree of convergence, how much they are converging. So what is the degree of convergence or divergence of a lens is called power of a lens. How much they are able to converge. Okay, now what is happening next? So, okay, we are done with the power of the lens. The focal length of the lens is minus 10 centimeter. Right, where we have to write the nature of the lens and find its power. Okay, next. Now the power of the lens is given by P is equal to 1 by F, where F is in meter. It should be in meter. This is the power of the lens, which is the reciprocal of the focal length, and focal length should always be in meter. Now the focal length of the lens is minus 10 meter, which means that it's a concave lens because the negative focal length is for concave lens according to sign convention, and it should be always in meters. So this is negative 1 by 10 meter. Okay. And write the nature of the lens and find its power. So what is the nature of the lens? It is because concave focal length is negative, so it is concave, or we say diverging lens. Okay, that is the nature. This is the focal length. We have converted it into meter. Now we have to find the power, which is 1 by F, and F should be in meters. So this is equal to 1 upon negative 1 by 10. That is equal to negative. And meter inverse, which is called diopter. So this is then diopter is the power of the lens. Okay. According to the new sign convention, what will be the sign of magnification in this case? So sign of magnification. What will be the sign of magnification? Sign of magnification will be positive. Okay. Because we know that the magnification is given by for the lens. For the lens, the magnification is V by U. And this magnification, the convex lens will have to magnify the object. So that means the objects are to be magnified so that the magnification has to be positive. So in this case, the sign of magnification is positive.